Welcome to this beginner's guide to train test split methods in Sklearn. The purpose of splitting the data is to create a model from the training data and then evaluate the model's performance on unseen data. Splitting the data into training and testing sets prevents overfitting, ensuring that the model generalizes well to new data. Well, in other words, that the model still makes adequate predictions on unseen information or new data. The split methods that we're going to cover today include train test split, train validation test split, and cross validation. An overview of train test split. This method divides a data set in two parts, a training set and test set. The syntax used from Sklearn is train test split from sklearn.model selection. Here in this picture we have the data set, which is 100% or the entire data set. We take it and we just break it into parts. 60% train, 40% test, and you can alter the percentages based off of the information that you have on your data or whatever your needs are. You use the train test split method when you have a small to medium sized data sets. That's when your data set is not very large, generally up to a few thousand samples. It's great when you need fast and straightforward estimate of model performance, and when you have limited computational resources or time. The train test split reduces the computational burden compared to more complex methods like cross-validation. The next method is our train validation test split, where we take our 100% data set, the entire data set, and we break it into three parts. Here I have 60% for train, 20% for validation, and 20% for tests. So with this method, we use the validation set to fine-tune hyperparameters and evaluate the final model performance on the test set. We use the train validation test split when we have medium to large size data sets, typically several thousand to hundreds of thousands of samples. Hyperparameter tuning, we use that on the validation set, and even we can choose our model using the validation set, and then finally testing on the test set. Cross-validation is our last method that we're going to discuss today. We use cross-validation to split the data into K subfolds or K subsets. We train the model on K minus one of the folds and test on the remaining fold, and we repeat K times. The purpose is to use all the data for both training and testing, ensuring a robust evaluation. So here we take our total data set and we break it into K subsets. So here we have this data set and we say I'm going to do 80% for training, 20% for testing, and then we take the data set and get another part of the data set and say 20% for testing and 80% for training the model. And again, we're going to take 80% for training and another chunk that's just 20% to test. So here we have three, as I mentioned, four subsets for training and testing the data, and the results of the model performance for each fold are then taken together as an average. We use cross-validation when we have small to medium-sized data sets, and cross-validation uses the entire data set for both training and testing, providing a more comprehensive performance assessment. This ensures that the model performs consistently across different subsets. Okay, here we are in our Jupyter notebook on Google Colab, and we're going to take a look at this train test split methods and see what it looks like, how the samples are affected with that. So what we're going to do here is load our library. So we're going to import pandas as PD, import numpy as NP for arrays. We will import matplotlib. Plyplot. We have this one. I love this plyplot. We're going to import seaborn as SNS, and from sklearn.model selection, we're going to import our train test split and our K fold. Run those. Let's read in the data set. Here we have df is equal to pd.read_csv, And the file we're working with is the same one that we saw in our previous data, which is the medical insurance cost data set that we use for regression analysis. And we also are going to take a look at the first 5 rows of this data set. So df.head, we're going to print that. I'm using the print statement here because I also want to take a look at the number of rows and columns in this data set. So df.shape, let's take a look. Here, charges, the amount of charges, the medical charges is the target or the outcome that we're trying to predict. And the input features are age, sex, BMI, children, smoker, and region. Today we're only going to look at one input feature, which is BMI, with that charges. And because we have a large sample here, and all I really want to do is show you what kind of impact the train test split methods have on the data points, I'm only going to use 2 data points. And I'm going to reduce this data set. So I'm going to just take a sample of this 2,772 rows. So to do that, we're going to call data is equal to df.sample, and we'll take a sample of, let's say 100, sample of 100, and we're going to create our X features, X data, and this is going to be for BMI, and we'll also take our Y value, data for charges. To train test split, we split the data into training 80% and test 20% sets, and then we're going to visualize the training data in blue and the test data in green. So to do that, here we have our X train, X test, Y train, Y test equals the train test split. That's for X and Y. And we're going to have a test size of, as I said up there before, 20%. We use a random state, so our random shuffle will remain the same. So we can get back to the same set of data that we chose before. So our random state is going to be 42. Okay. String. String, which we want to have a color. Our color is going to be equal to blue for the training data, so we're going to have blue. I want it to be somewhat opaque, so or transparent, so we're going to have alpha is equal to 0.5. And we want to have the same for the test. I'm going to copy this here. Now I have X test and Y test, and Y test. And this time we're going to have a color of green. Let's have the title to this PLT title. I'll call this train test split and add the legend. PLT.show so we can actually see it. And there we go. Alright, so this is what our data looks like. So when we do our train test split here and we decide to take a 20% test size, those are what we're seeing in green. So that's our 20% that we're holding back to test the effectiveness of our model that was created with the training data that's in blue here on data that it has not seen before. Okay. Let's take a look at the training validation test. And to do this, we're going to take our X train X temp and create a temporary file, a temporary data set or sample. And we have our Y train with our Y temp set equal to test. There we go. And we're going to have our, again, X and Y. And in this situation, I want the test size to be equal to 60% for the training data. So since the training data, I want it to be 60%. The remaining, what's left over for our validation and test will be 40%. So the test size will be 40%. And we're going to have a random state for reproducibility of 42, like before. I'll have to do the same thing again, except we're going to replace the training attempt. So I'm going to copy this, and instead of having X train, I'm going to have X val, X test, Y val, Y test, and this will be for their X temp and Y temp. So here we're going to have X temp, and this is going to be for Y temp. And instead of 40%, since we only have 40% remaining, we want half, so I want to put 20% in each one. So here I'm going to make this half of what's left over. Half of the 40% will give us 20% for each one. So that's 0.5, one half of it. There we go. Okay, 50%. And as before, we're going to do a scatter plot. The training data will be in blue, the validation will be in orange, and the test set will be in green here. Now let's go ahead and take a look at this one. So when we look at this here, we can see that these are the values that were for training. We'll create the model or the equation that we want to use to do our prediction. In this case, we're looking at regression, so we're trying to predict charges. And we will validate it or work with it and do any hyperparameter tuning that we want to do, or compare different models on using this validation holdout portion of the data set or sample. And then finally, we will solidify our findings on the test data. So then we will go ahead and finalize the model on the test data. Basically evaluate it on the and get what the results will be if we truly had absolutely had never seen the data before. So this is the final holdout as the test data. So for the cross validation, here I take values so we can ensure that X is a numpy array, and the same for Y. And to run our k-fold cross validation, we instantiate this variable or this name kf is equal to k-fold. The number of splits is 5. The shuffle is true. Shuffling allows for you to actually shuffle the data before doing the splits. And so in the random state is 42. We're going to look at the fold colors. The colors will be from HUSL palette. If you type it in, it's a seaborn palette of colors. And it's 5. So if you go HUSL for seaborn, HUSL seaborn. This is the palette, okay, palette choice. Also, if you want more information from Sklearn, the Sklearn for k-fold cross-validation, they tell you about the shuffle. And so here, shuffle, whether to shuffle the data before splitting into batches. So here we say, yeah, we want to shuffle the data before splitting into batches. So its default is false, but here we say it's true. So I'm going to shuffle the data. That's true. And we are going to take the figure. We're going to actually run for each one of the folds and create a scatter plot for each. Okay, and so this is our training data. And pay attention to the color of the dots. See, the dots line up. They're still the same here. But you notice the colors the change. So the validation moved on to different data points. So still same data, but what becomes part of the training and validation changes with each fold. Okay. To get an idea of what's happening here, we can kind of break it out. So we can take this 4-fold, this part here, and print the fold, print the train index and we'll do the same for the test index. And I don't want to like have to rewrite it, so print the bold, and so now we want it for the test index, so you can take a look and see what's happening here. And so what you see here for the fold of 0, the training index, these are the data points that we use to train the model, and this is the part that was left out for testing. So this is training again and then testing. So what happens is you create an equation here, you validate the equation over here, and so you get some sort of accuracy measurement. You do the same thing here. A new model is trained on this subset of data, and then it's tested on this holdout piece of data, and you get an accuracy measurement. And so from each of the accuracy measurements that you receive, you then average those results to give you what we would say is your final accuracy for the model. And so this is for k-fold cross-validation. Again, this is great for like small and medium-sized data sets, but for larger ones, this is too. It can be very time-consuming and maybe not the best use. And when you have more data, you tend to have a clearer picture of what you're working with anyway. So yeah, so that's it. I hope that you enjoyed this video. Give it a thumbs up if you like it. Subscribe. I really appreciate you for taking the time out to look at these videos, and I really hope that I can help somebody out there. So yeah, until next time, be well.